Okay, so thank you very much for starting the recording. Good evening, everyone. And then I believe you can see my screen. So today we are going to start the first seminar in actuarial mathematics. So overall, the essence of the seminar is to allow us to see the practical things we are doing during our coursework in probability. So here we are going to explore different data sets. We are going to see how we can apply those things we learn in class, how we can apply probability distribution, different types of probability distribution. Because I think one of the challenges that actuaries face today is knowing the distribution of a particular data. So supposing you are working in an insurance company and you are presented with a huge amount of data, and then maybe based on this data you are asked to price some certain product. So given this, the first thing that will come to your mind, what type of distribution that this data follow before you can model it, because all the data we are modeling today is based on probability distribution. Yeah, whether it is for pricing, whether you are developing some risk model. Yeah. And for example, you also maybe happen to work as a manager in your, let's say, supermarket, for example, and then maybe you have this kind of issue that customers are waiting a lot in the queue. So maybe you don't know, you don't have appropriate number of counters that will be operating during the day. It's a very tricky stuff because, for example, on Monday you have more customers, Tuesday you have less customers, Wednesday you have more. It's something that is alternating. And then you gather a lot of data on the number of customers that are showing off, then with the waiting time, how long they stay in the queue. And then some customers, there's this kind of behavior that if someone just come to the shop and see that the queue is long, they decide to go. And people tend to join a shorter queue in the supermarket. So this is a kind of, let me say, complex network that one need to model. So you need to understand in an event where you want to model this situation, in order to optimize your business operation, to optimize your profit, to optimize the number, to know exactly what day should I open more counters. I mean, you save the number of workers, and then you optimize your your profit. So when you are presented with different kind of data set, this data set will tell you everything. Yeah, this is what we need, and this is what the data is speaking. But you start modeling, thinking about how to model this data. The problem is defined. This is the key step. You have the data, the problem is well defined, you know what to do, at least 50% is done. But then, how do you know the type of probability distribution that you will apply? One can say, yeah, it's okay, I can use, let's say, exponential distribution because it's dealing with timing. But you need to test, you need to do some statistical analysis to determine whether exponential distribution is applicable to your data set. So overall, to cut the whole talk short, that is what we are going to focus on. So today is the first seminar, and then the plan is to just introduce or to tell you the overall goal of the course, and then introduce some basic things. Um, we are going to look at some things that were covered during the coursework for today, because yeah, we need to have some kind of understanding or a deeper understanding of probability. By then next week we can start looking at some example, and in the future, maybe somewhere in the middle of the course, then we are going to explore different data set. We are even going to use a practical. I have a real statistical data for Nigerian health insurance scheme, because there was time price I price insurance contributory health scheme for Sokoto State. I also do for the national in general. So I have some kind of statistical data set that we can use for our learning purposes. Yeah, and then we are going to also explore other data outside, and in case you have some data set maybe from your work, you can keep it as confidential as possible. I know those information you don't want us to see, you can remove them, then we can try to, but this is not like mandatory, this is just a voluntary part of the course. If because student will be having, or let me say participant will be having some exercises, let's say in class. When we start showing you how to do this analysis, then you will be given some exercises to perform this analysis by yourself. So yeah, most of this analysis we are going to use Python as well. uh, that is why it's good, and we are far, or let me say we are ahead in Python and probability course than the seminar. So yeah, I believe you have started doing something in Python. In fact, don't worry. When I mention Python, we are going to use it. I'm going to show you how it's going to do. We are even going to do the coding together in class, and then I will allow you to go and practice on your own, and then solve some exercises and present them during some classes. All right. So I will show the overview. I will go to the next slide. Wait, how can I do that? Sorry for. I need to. Can you still see the screen? Because I change. Can you still see it? Can someone confirm if yes?
Can see.
Okay, so if I change this slide, can you please confirm that it's changing also? Yeah. Yes?
Overview.
Okay. Okay. Thank you. All right. So the overview. The first seminar center on probability, like I mentioned, and distribution. Provide students with an in-depth understanding of statistical analysis and quantitative risk modeling. It enables exploring into various data sets while comprehending the application of different probability distribution. So that is what we are going to focus on. Two ways. One, we are going to see the application of this probability distribution in actuarial pricing and in valuation. Two things are involved in general in business operation, whether it is actuarial or banking. First of all, product control. If you are controlling your product control involve pricing, maybe some offering, advertisement, and stuff like that. Yeah, that is in general. And then we have valuation. So valuation is done. Some companies did it, let's say annually. Some after 2 years, some after 3 years. Valuation involve some kind of risk management stuff to see your return in investment if you are investing in something, to see your chances of going into ruin, to see what the company will look like in future. So all this, they use data, and what data they use depends on how the company is operating. They may be using futures data outside, they may outsource data, or they have to use their historical data. Yeah, so that is what we'll be doing throughout the seminar. Yeah, it's kind of, let's say, the seminar should be more or less interactive. So please feel free to jump in to share your ideas, because two things are involved, let me say, in learning. If you are educated, maybe you may lack ideas. You may be you may be educated, yeah, and lack ideas, and you may have ideas and then you are not educated, you cannot implement those ideas. So that is why if we are in an environment like this, it's kind of more of brainstorming, exchanging ideas. If I bring idea A, then I'm just having the idea in my mind, but I don't know how I can use it. Yeah, someone with the knowledge, yeah, great idea. So this is how we can do, and then solve problems. So please, let's make the class as interactive as possible. Yeah, as since it's seminar, and whatever we are going to do is going to be more or less real life. Okay, so here we see the outlines. So first we are going to look at introduction to probability. This is kind of a theoretical part of the seminar, because we have done this already during the courses, but yeah, we will repeat a lot, in order to have better understanding. Maybe something is not clear there, we can we can have a chance to ask question or even have a better understanding after explanation. Then we look at types of probability distribution used in actuarial science. Yeah, because there are a lot of probability distribution. I can tell you, I and my colleagues, we did some work. We like, maybe we'll use that distribution because we invent one kind of probability distribution. You, as an individual, if you're a statistician or mathematician, you can be able to come up with your distribution. Distribution is not like, when you hear, it's not like something that is it's a lot of rocket science, to be honest, but it's not something that maybe that evolve just like that. Some people sit down and this thing is always developing. There are a lot of distribution. So many people come out with their distribution based on the data. Yeah, so it's definition. Mathematics is definition. When you define something, you define all your parameters and everything is mathematically coherent, then it could be accepted and it can work for your data set for a particular scenario. So a lot of them. So, but there are like common ones we use normally in uh, actuarial science. For example, normal distribution. Mostly we use normal distribution. Um, if, for example, you want to model the number of claims after 1 year period, you want to model the number of claims in your company, then you have to assume that this data follow a normal distribution. You can assume that this data follow a normal distribution because that is the challenge. You have a data, you want to model the number of claims or the number of severity, and and you don't know severity. Yeah, claims are synonymous, let me say. um, and then you don't know the the distribution. So you need to, do some statistical analysis to determine which distribution. But if you want to do this distribution, for example, today let's say we have 100 types of probability distribution. You are not going to do the statistical analysis on top this 100 probability distribution. There are specific one that you can choose. Let's say four. You may decide to choose Poisson, Bernoulli, binomial distribution, exponential distribution, mixture of exponential distribution, gamma, Weibull, and these are the ones that are most commonly used. So you can decide to pick four out of many that you think they are more applicable to a data set, then perform the analysis, out of which you just pick one based on some result of your analysis. Yeah, okay. So the next we are going to look at application in quantitative risk modeling. So here we are going to do some quantitative risk modeling, just like something we start doing in risk analysis. So when we go for it is kind of connection. What we learn in risk analysis, what we learn, that is how we design the course in general. Whatever we are doing in risk analysis plus what we learn in probability, we put it together and try to put something during the seminar in such a way that you will have a better understanding and you can see where we can apply this kind of situations in real life. So we'll do some quantitative risk modeling. Yeah. So for example, solvency or trying to calculate the probability of ruin of an insurance company. Yeah. So you have so many probabilities. For example, you have what we call uh, initial capital. You are starting with a kind of initial capital as an insurance company, and then plus what? Because that is your total, let me say, your total portfolio or asset. You have initial capital plus the premiums you collect from individuals, and then let's say minus, yeah, this time is minus the benefit you give out, the claims, yeah, and then you can also add a plus which we call safety loading. This is we will see it, we will do it. I'm just giving you an example. So you can also add a safety loading. This safety loading is also a surplus. In case of something did not went right, something is adjusted, government come up with some policy before you implement, then you are still giving out let's say, because if government, the problem sometimes government may implement a policy today that okay, the VAT rate, the value added tax rate is drop, or the inflation has increased, which is maybe affecting the price of drugs, yeah, and then someone come with a claim that, okay, I it's the claim of being sick, then you have to pay for these claims, and this claim have changed eventually. Before you go back and price your product again, make some changes in such a way that you will go in line with the inflation rate and the taxes and whatever. uh, you don't have time and claims are coming in. So in this situation, you will see that you will have some loss. Yeah, if things will not go as planned. So that is the importance of surplus. We call it um, risk adjustment or safety loading. So in case something didn't go right, so we will see all those things, how we can use them or we can incorporate them into risk modeling or risk models. Okay. So here we look at application in actuarial pricing and valuation. This I already explained. I mentioned how we are going to apply this data in actuarial pricing. Mostly pricing. So if we talk about pricing, it could be anything. But what we are going to focus on is pricing insurance product. Mostly in is insurance product. So because it's applicable, you can decide to price other things, just that the model will be different. For example, if you are into option or you are into derivatives marketing, you are into option, you know what option. So some people that have financial knowledge, they may understand what I mean. If you are dealing with derivatives, for example, option. Okay, the simple example I can give you is contract. Let's say swap and future contract. Um, Option is just if you are maybe you want to, let me just give you a typical example. How should I cite an example? I have this phone and then I want to sell it in the future at rate of $50. I don't want to sell now, but I want to sell it in the future. So I can decide to buy a a put option. Yeah, it's called put option this time around, not a call option. So because there are two types of option, there are many of them. We have European option called sorry, European option. We have American option. So this doesn't, these names are just names. They doesn't mean only European people do it or only American people do it. It's just a name, it's type. So if I have this phone and I want to sell it in the future, I don't want to sell it now, I can go and buy a put option contract from someone that is willing to buy the phone. Yeah, I will tell him that, okay, the price of this phone is $50 today, and I want to sell it at that same rate even in the future. But how can I assure you that I will buy this phone at $50 without you giving me anything? You have to give me some benefit for me to buy this your phone at the rate of $50. So the thing is, I will have right to sell this phone at a particular price during the maturity date. Maturity date means when the agreement, the contract between me, the option seller, and the buyer reach agreement. For example, in 3 months, let's say in 3 months you will sell this phone. I will sell this phone to you at rate of $50, and I give you $20 for you to give me this right. Yeah, so it's right, and it's not an obligation. That is one interesting thing about it. It's a dating game anyway. Yeah, so it's not an obligation. If maybe I on that day I want to sell the phone to you, in the market is $55. While we agree I will sell it in $50, I give you even $10. So I may decide, no, I'm not selling again. I'll go to the market and sell. Then I will have $55, but the $10 I give you is your own. And I lose it. But maybe if the price in the market on the day of maturity is maybe $30, then of course I'll sell to you $50. Then I have like $20 profit. So it's anyway, it's a dirty game people in finance do. So you can decide to do also. It makes a lot. You can make a lot of money. So yeah, you can price this kind of product. There is a way we do it. You can price options. You can price, you will know how you can price them. There are different models like binomial tree. This is the most common model used in option pricing. All right, so valuation I explained in the end is kind of risk analysis to see your solvency level, to see your amount of capital, to know the chances that you will be into ruin, or for how long will you be operating without any having financial catastrophe. Okay. So the next we are going to look at different data sets. So this one's we are going to just explore this data. When we are exploring data is to visualize data by mere looking at it and also using some statistical analysis. So I know in this case we will be more or less using Python. So please, I would recommend you focus very well on Python because it will help actually very well. And some people that are familiar with Excel, because I know some people that are familiar with Excel or any statistical software. We have a lot of them. We have R, we have Stata, we have Excel. So, and some people use SQL, of course. Yeah. So, anyone you are more familiar with, there is no restriction because this class is flexible. I don't know all of them, but I have knowledge of, let me say, almost some basic of some of them. Excel is fine. I 100% know. I mean, in data analysis, not 100%, but I mean, I know how to use it, Excel, just like I know how to use Python. Also R, yeah, not 100%. So if you happen, I'm telling you this because if by chance you want to use one of this, I will tell you for how much I can help you and how much I can contribute to this. So that you'll have some level of expectation on those. If you are using Python, fine. You can expect me to assist very well, and Excel also fine. So this ones, we can use this kind of statistical softwares in case of our data analysis. For the case of the class, we are going to use Python, but if you know or if you are familiar or comfortable of using other statistical data, please, you are welcome and feel free to use them. All we need is the result, and of course, we will have the sum result. Yeah. Okay. So far, do you have any question before we can continue? Anyone with question? I will assume no if no one is raising their hand or no one is saying anything. Okay, so we can proceed. All right. So that is about the outline. This is what we will be looking at in general. Okay, so today we are going to, like I mentioned, it's more or less introductory class. One thing I need to mention is about the activity. So I think I mentioned earlier, but for the sake of those that just joined, we are going to have more of class activity because this is seminar. You will be given some exercises based on what we have learned, and then you will perform this kind of data analysis by yourself. That is why I mentioned that if you are familiar or you want to use other statistical softwares other than Python, feel free to please use them. Yeah, all we need to see is the result. Yeah, so there is no restriction or limit on what statistical software will be used. So you will be given some exercises, and then you will be doing the the exercises on your own, and then when we come you present the result. So this can be sometime in group, this can be individual, so depend on the kind of problems. So I will have time to dig out all those exercises and then see how we are going to uh, plan it. And please, if something like is not right, or you have some comment on how we are going to structure, it's flexible, you can just, okay, I think we can do it this way, and yeah, we'll look at it, and then if it is fine by everyone, then we can use it. Okay. So let me go to the next slide. I have so many things open already. Okay. All right. So let us look at a few introduction. I to be honest, I write this like now, not few minutes ago because of the timing. Yeah. So introduction. So the following piece of jargon frequently occur when discussing probability. I believe most of them you see in during the courses, but we are going to explain one more time. I write a lot of things for everyone to see. So event. When we are talking about probability, first we have to discuss event, because whatever we can just tell probability. Probability of what? It's probability of an event, certain event happening. So let's understand what an event mean here. A thing that you can observe whether it happened or not. So that is an event. An event of going to market, on an event of accident happening, an event of maybe someone being sick, an event of rain falling today, all this event. So a lot of them rolling a die, toasting a coin, and dress like that. So that is what it means by an event, a thing that you can observe, whether it happened or not. So um, then probability is safe. The chance that an event happen, or a scale, from zero, on a scale from zero. So we put it scale from zero in such a way that probability. This probability lies between 0 and 1. So scale that when we say something is not happening at all, that is completely not happening, is the probability is zero. Yeah, cannot happen. And to one, always happen. So this is like 100%. For example, probability of let's say, what is, okay, probability of death. Because in actuarial science, actually, this is very vital question. Many people ask this question, and I remember I was asked during the seminar here, some in Germany, in July 2022, uh, when we went for seminar with the Alliance company. uh, they ask about what is certain, because we are talking about life insurance. Then someone want to price some product, or someone want to buy insurance contract, but they ask, okay, what is certain in the event? What is certain is death. You are buying a life insurance contract. What the probability of you dying is 100%. So they consider this. But then we don't know when. Maybe if we talk about probability of dying in 1 year, then in that case, uh, you can say no, I don't know, because we don't, except by some factors, maybe your age, your health status. You see, maybe someone is very sick, or they are going for a war, for example. Maybe they like this war happening in Ukraine, if you are a military serving there, or what is happening in Gaza and Israel, and then you want to buy some insurance product. You can buy a term insurance contract in this case, because uh you know that there is high chances of you dying during the event, even if you are going there to serve for 1 year or for some month. Yeah, but you are just sitting in your house, everything is fine, though it's inevitable, but you can't just think about it, and tell the probability. All right. So in general, probability is P. Then if we put something in parentheses, then we call it P of event. So probability of something here, probability of any event. So if it is well defined. All right. So the next one we have, like, probability universe. This is a jargon. People can say union, or superset, or whatever. So if you have some, if you are a mathematician, you may have, this is like elementary stuff. You have some knowledge of set. So this is like the probability space where all the event you are considering can either happen or not happen. So superset, if you have a collection of space, sorry, yeah, a sample space, a collection of event. So the probability of all of them, is probability universe, and that's how we define it. It's more or less just a superset. That's it. So we have mutually exclusive event. If one event happen, then the other event cannot happen. So something is mutually exclusive. I give example. You cannot roll a die that is both 5 and 1 at a time. So it's a typical example, because I remember the last class we have some kind of brainstorming about definition of mutually inclusive and exclusive. So I give example. So you can roll a dice that is okay. Maybe someone is raising their hands. No. Okay. Sorry. I need to read. Okay. So this is talking about attendance. There is a Google form. Halima drop in the chat. So please, you can just open and sign the attendance. Okay. We can go back. So apart from this, can someone give me an example of mutually exclusive event, please?
Can we talk about life and death? It's not possible you live while you die, or you die while you live.
Yeah, yeah, it's true. Okay. You can give another example. Yeah.
All right. Don't want that one.
Yeah, because
Okay. It's
I
not
don't know if we are modeling this kind of situation, it will be tricky. Yeah, nobody will agree to be in the fit of dying. Yeah, but yeah, okay. So if you can give another example, or someone can just give us an example, that would be appreciated. All right. So Kahinde, you have your hands off. So please
Oh,
go
oh,
ahead.
oh, okay, thank you.
Yeah.
I, I'm looking at the scenario whereby maybe I have two marble in a box, one red,
Yeah.
one white, and I have
Yes.
to pick one marble at a time.
Yeah.
So the probability of picking white is or the black is
Yeah.
mutually exclusive. I don't know, but I'm just thinking this.
Yes, it's true.
Thank you.
It's true because you are picking at a time and you are not asked to pick all of them. Yeah, so you are picking one. So there is mutually exclusive. You can either you just have to pick one. So that is why you cannot roll a die that is both 5 and 1. If you roll a die, you drop it, you just have one face. It can be 5, but it cannot be at the same time 5 and 1. So this is example of mutually exclusive. Maybe someone have other examples. No, okay, so we can proceed. Thank you for all. Thank you all for the contribution. All right, so let us see others. So independent event. Yeah, last week this is something also we discussed, so I bring it up. If one event happen, it does not affect the probability that other event happen. So you see the differences now. So here we didn't talk about exclusive. Sorry, inclusive. Inclusive is the reverse. So it's easy. So independent event, if one event happen, it does not affect the probability that other event happen. Example, the weather does not affect the outcome of a die rolling. So true. If maybe it's raining or it's not raining, the probability, for example, of rain today and will not affect the probability if you are playing. You cannot even put into consideration the weather because they have all different kind of probability. So the outcome of die whether it's rain, if it is one, is still one. If it rain, if it is two, sorry, if it is one without rain, it's still going to be one also. So that is independent event. And then we can also look at I don't know because for example, if we are pricing insurance product, I mentioned this. If someone is sick of, let's say, is sick of malaria, for example, so the probability of someone having malaria is completely independent of probability someone having HIV. That is the assumption we used to have. Not even HIV, even other disease, let's say typhoid or some typhoid, because we assume that we there is something we call IDD. All event, all claims are independent, identically distributed. Because without this assumption, it's very very difficult to price insurance product, especially health insurance product. Because if you ask a doctor, someone with malaria, can he have headache? Say yes, he will have headache. He will have fever. And you can have headache without malaria. It's something can cause it. Maybe you didn't sleep the whole day, and then you have some headache. It's not like you have malaria. Yeah. So in some cases you see they are independent, but while in some cases they are dependent. So in general, we generalize it and then assume that all claims are independent, identically distributed. Yeah. So that is the definition here. Yeah, I'm giving this example because we'll be using them when we start citing examples. So dependent event. If one event happen, it changes the probability that the other event happen, e.g. the weather affect the traffic outcome. Yeah, so it's true, yeah? And can someone give me example of dependent event apart from this? Here is obvious, it's clear when it is even, for example, it's over snowing. You have to drive slowly or it's over raining. it's raining heavily, not over raining. Sorry for my English, but it's raining heavily, and then yeah, you have to low down, and then it affect the traffic outcome. So this probability, let's say if probability of snow today or heavy rainfall today is 1, then the probability of sorry is maybe 0.5. The probability of traffic can be zero point 0.5 or even 0.7, because it's these two are connected. So someone should give me example of dependent event. Just think. Please go ahead. Thank you.
Okay, sorry. I'm just thinking of this also.
Okay.
Um, I'm looking at one event which is driving.
Yeah.
I'm looking at another event, getting drunk.
Okay.
Sorry, not driving. Having accident while driving. That is one
Yeah.
event. Then the other
Mm-hmm.
one, getting drunk. And
Yes.
I'm looking at the that having accident while driving might be
Affect it may be
affected
dependent on
by
someone, let's say status.
exactly
Yeah,
this.
if he's
Exactly.
drunk or not.
Yes.
True. This is a very good real life example, and thank you for your contribution on this. Maybe someone can give us another example. These are elementary. I'm sorry, because yeah, we just have to have understanding, because this is real life situation. I can just leave this. You read on your own and you understand them. But because of the fact that I didn't prepare or plan to start going into the technicality of the course, that is why I just make it as interactive as possible, and I hope you like it that way. Okay. So the next one is uh, this one, conjunctive probability. So we call it also joint probability. So the probability that all event happen. So they are joint. This joint the probability that at least one event happen. So if uh, can someone give me example of this? I didn't put the example just for us to discuss. Maybe Ibon, you can give us, or Sahon, or Mr. Alagbe, maybe you can tell us. And welcome, because I think this is the first time I'm seeing you. Yeah. So can someone volunteer? Sharabilu, please tell us.
Yeah, sorry, I'm battling with network. I'm having some glitches.
Yeah.
So I just
No problem.
come back now. Example of what exactly?
Uh, Conjunctive probability, or a joint probability.
Okay.
A joint probability. I mean, if you cannot remember, it's not a problem. I know you can forget stuff. Yeah, it's fine. Yeah, but someone I think should tell us, the
Okay.
probability.
Good evening.
Yeah, good evening and
Yeah,
welcome.
thank you for welcoming me.
Yeah.
I was just thinking of having a set of different balls. Maybe you have a basket with a red ball and
Mm-hmm.
white ball.
Yeah.
Uh, Probability of picking a white and a red ball consecutively, if you are allowed to pick two times.
Mm-hmm. Or if
Probability
you're allowed to pick the same type of ball at the same, or different type of ball, sorry, at the
and
same time.
or different,
Yeah.
yeah, probability of picking different kind of ball uh, uh, consecutively. Maybe you're asked to pick
Yeah.
two, and then probability
Yeah.
of picking different ball the first time and the second time. It has to do with probability of picking a white ball and probability of picking the red ball.
Yeah.
If they are in the same basket.
Mm-hmm.
So somehow, since the number of red ball and white ball are not the same, even if they are the same sport, since they are in the same basket, there's a
Yeah.
way that the number of chances of picking one white or picking one red ball will affect the chances of the other one. I
Yeah.
don't
But
know if that
yeah, yeah. I
example.
mean, here, according to the definition, yeah, it's you are making sense. Here we talk about probability that all event happening. So it's true. If you are asked to pick, from basket that contain red and white balls. So there's chances. The probability that picking white or picking red is possible. So all there is probability. The probability of the event of taking white or the event of taking red, it can happen. So it's we can call these two probabilities as joint probability. Probability of picking white and probability of picking a red ball from a basket is joint probability. Yeah. So it's also, you can also define at least one event here, the probability that at least one event happening, so in the same pattern. Okay, so please think about more example. If maybe you go on your own, you can think about more example. Here we can see in this case the kind of axioms that we use in this case, especially this one. But this one is more or less in games theory. We
Yeah.
use them. The most important are the dependent, independent, exclusive. These are the ones we use in industries mostly. But these ones too can be. And conditional, very important. Conditional is very, very important. The probability that one event happen, given that another event happen. So can someone just give me example? I think this one is easier. Someone want? Okay, thank you. Please go ahead.
Okay, thank you.
Yeah.
Okay, sorry. Um, just allow me, but I'm not
Hmm.
sure if this is right anyway.
No problem. Please feel free to talk.
Okay, so
Our expectation is not to for you to know
okay,
100%. So
okay,
yeah.
thank you. So um, I'm defining an event,
Mm-hmm.
swallow. I mean, when one is eating, of course,
Yeah.
after chewing, you swallow
Yeah.
the food. Then the other event is that this food gets into the stomach. I'm very sorry.
Yeah.
I'm just trying
Yeah,
to
this
find
is
an
like
easy
a
way
kind
out.
of very, very, very good example, but it's a kind of funny
So,
example, but it's true.
uh, so but I'll think of another more acceptable one. But this is what
Hmm.
I
Hmm.
can
Please go
just
ahead. It's
quickly
acceptable
think
as
of
well.
that. Uh, of course, if the two must go together. Once I swallow something, then the other end of it getting into my stomach, it must definitely happen.
Yeah.
I'm also trying to look at the case of a vehicle that has a flat tire, as
Yeah.
having a flat tire being an event, and the vehicle being stationary, not moving, being also another event. Once
Yes.
there's a flat tire, definitely the vehicle will not move. It will,
Yeah. The
it will
probability of
stay
vehicle not to move, given that the
flat tire.
vehicle has a flat tire, so it's
Yeah,
conditional.
yeah.
And another typical example I can give is insurance product. Yeah. It's conditional, of course. The paying benefit is conditional of a claim happening. For example, you buy a car insurance. A car insurance, for you to get the benefit, there must be claim must happen. Yeah. So the probability of claim here must be equals to one. That claim happen, then you will be given the benefit. Yeah. So this is like another example. This is condition. You are buying a product or anything in real life. Just think about it in real life. Anything that has condition, just
Yeah.
think
For
about the
example,
condition and the event of something happening. Yeah,
yeah,
sorry,
like the
go ahead.
probability of developing lung cancer, given that someone is smoking, I think is also a conditional, right?
Yeah, given that someone is smoking, so it's
Yeah.
conditional. But maybe
Mm.
if you didn't smoke at all, you cannot have cancer. For example, lung. I don't know if there is lung cancer.
Yeah.
Lung cancer. I'm not a health specialist, but although I work with do so many pricing, so in
Yeah.
sometime when I'm pricing some product, I have to call expert that are in health. So please help me if someone have malaria, can he have this? So from there, just to have an idea, or I see
Yeah.
some terminologies. I collect so many. so many data on number of on type of diseases. I see so many pediatric different difficult names, and then
Yeah.
also information on drugs. See, one I can't even read it. I have to look very so many times to see if it is really English or Chinese. Okay, just joking. So
Yeah.
yeah, that is conditional probability. So, do you have any questions so far? Because I think we are going to wrap up the class today. I have more to discuss, but I didn't include to into the notes. But I believe if I send you the note, I will just like I present this note with example, you will be able to understand. So if you have any question, you can ask, or if no, if you suggest, I can just read it or tell you about other definitions, the basic things. Because by the time we cover all these basic things, we are good to go. We can start all what we need to start in our, I mean, in the main course, our data analysis and stuff. So I believe you have the understanding, so we can start looking at the distributions because this is basic. For example, I plan to include like odd probability multiplication rule. Yeah, that one is more or less mathematical. Then give example of dependent event, how we define them mathematically. Give the example of disjoint sum fallacy. Yeah, and yeah, I can include this in the note and send to you. So next week before we start the main thing, then I can give a recap of what these things are. But of course, I know if I include this thing in the note, you will be able to read and understand them. For example, addition rules. So how we use addition rule and how we define them mathematically in different cases. Then we see disjunction fallacy when we are adding. That is when we bring about this just disjunction fallacy, and then give a typical real life example. I will put this example in the slide and you will see it. So you will be able to decide how, sorry, you will be able to understand how it's going to be. Then we are going to look at bias rule. Some people that go deep in probability know it. Probability of an event happening, given that another event have happened, is conditional. So the whole conditional probability came from bias theorem. So we'll see also this theory. Yeah. And then from there we can close for the introduction and then start something. So do you have any questions so far? No? So I will assume no. And thank you very much, everyone. This is already it, and then we'll see next week. Apologies today, we have not done much, but yeah, I believe it's enough. The important thing in this seminar, you need to understand the technical. That is what we are doing, and then we start the applications. So just you can see how we apply this thing we are talking about in real life. Okay, and then sorry, just one thing, please pardon, Mr. Alagbe, if you can introduce yourself. I can just quickly introduce myself for the sake of you that just join, and then you can introduce yourself to others. Perhaps if time permit, we can just, yeah, get to know each other well.
Oh, good evening, everyone. I'm Lagbe Babatunde. That's my name. I'm ICT teacher, and I enroll for the modeling and computational science.
Okay, nice.
I reside in Dev City.
Okay, that's interesting. And maybe your background, you mentioned computer science, right?
Yeah,
Okay.
I have knowledge, BSc mathematics.
Mm-hmm. Interesting.
Then I did something on computer networking.
Okay. All
Then
right.
currently I'm teaching in a school handling
Okay.
IC, their IC.
Okay. That's nice. And nice to meet you. Good to have you
Thank
here.
you.
Yeah. So my name is Ilyasu, and I have bachelor's degree in mathematics. I have master's in financial and actuarial science. I also have certification in data engineering. Uh, Basically, big data analytics. And then, based on my experience, first I work at this institution, Helpman, as research analyst uh, from March 2019. till date. I was working initially as a research analyst and focusing on population models in demography and health cluster, and then later on working as associate and then working in actuarial science, so mostly in pricing. Yeah. My second experience is Wiley Edge in the United States. I worked there as financial analyst also, but just for a few times, let's say 5 months, and then I moved to uh, Bank of New York. So there I work as accountant during the first year in private equity. So now I'm working as an associate in the same bank, but in private equity, but more or less NAV valuation and solvency. So kind of risk analysis. Yeah. So one also is Alliance. There I work as a junior quantitative risk analyst. Yeah, that one also just for I think 5 months, not long. So that is all, and thank you for joining today. So we can just wrap up the call. Sorry, I just want to. Yeah, I'm sorry, I was attending to someone. Okay, so do we have any question, or we can just wrap up the call? Maybe no. Okay, so thank
Hello.
you.
Yeah. Hello.
Yeah, the class supposed to what I was called. They called my attention on one thing. The class supposed to end like in 2 hours, but we just spent 1 hour. So this is introduction. To be honest, I didn't put together a lot of information. So please pardon me for not taking you up to 2 hours. So the next class,
Uh,
just
are
brace
we going
yourself.
to have this slide? Can we have this slide
Yes,
immediately?
once I finish the slide, I will send to you.
Okay. All right. Thank you.
Yeah. So next class, you should expect us to cover the timing. All right. Thank you all. I'll